Hello and welcome to my channel. In this smart video tutorial, we want to prove that cos theta 1 0 minus 1 2 cos theta 1 0 1 2 cos theta is equal to cos 3 theta. So you can try by using the determinant of matrix to get the determinant of this and then compare it to the left hand side, but that will take some time. But the method I would like to use to fast track this process is the method called the sarus method. Sarus method. So how is this method like? What I need to do is to rewrite this expression and then duplicate the first and the second column outside the modulo sign. This is what I'm talking about. I will have cos theta 1 and 0. I will have also 1 2 cos theta. I'm writing everything I'm having there. 0 1 2 cos theta. So I'll close the parentheses, or sorry, the modulo sign. So I'll cover the line, and then what I need to do is to duplicate this, rewrite the first and the second one. So I'll bring it forward to be cos theta 1 0, and I will have also 1 2 cos theta and 1. So what again am I supposed to do after doing this? I'll need to cross these three. Of course, I can't cross only 0. I can't cross 2. It must be up to 3. When I cross this, I can also cross these 3. I want to cross this. The reason is because I want to multiply them quickly. So how do I cross? So let me do it in such a way that the line will be a bit straight. I'll just cross this over this like this. Don't worry about the line not being straight, but at least you understand what I'm trying to. So that's what I intend to do. I'll still do that for this one across this one, across this 0, and these ones are positive. They go with positive sign, and this is the last one that covers up to 3. Okay, it also has a positive. Check, this is not up to 3, this is not up to 3, and I believe you're getting what I'm trying to communicate right now. So this also is up to 3, so I also double cross it to this point. But what I need you to know is this part is negative, and this is up to 3 too, so I have to double cross it like this, and this is negative. And the next one I need to do is this 3. I have to cross this. This is negative. So we have positive, 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 negative, negative, negative. Just check how I'm going to get the answer in 1 second. So the next thing I need to do is to multiply through these ones. Keep in mind that they are having positive sign. So you have cos theta multiplies by 2 cos theta multiplies by 2 cos theta. 2 times 2 times 1, that's 4. Then cos times cos times cos, that is cos cube theta. That's the third power of this cos. Because cos times cos is cos squared, times cos is cos cube. I hope that's clear. Again, 1 times 1 times 0, that's 0. So we have plus 0 because it's positive sign. 0 times 1 times 1 is 0 plus 0. Alright, we are done with this. So let's go across this other part. 0 is here, so as long as 0 is present, if it multiplies by this, multiplies by 0, it will definitely give 0. Why am I using negative? Because these ones are negative. I'll still have minus 1 times 1 is 1 times cos theta is cos theta, and then finally 2 cos theta times 1 will still give 2 cos theta. All right, and of course you know that the whole of this is equal to cos 3 theta. All these are the properties of this, and they are equal to cos 3 theta. So let's simplify this. Of course, 0 plus 0 minus 0, that we cancel out. So we just have what is left is 4 cos cube theta minus, because minus cos theta minus 2 cos theta, that is invincible 1 here. So that one will add up to this to give minus 3 cos theta, right? And the whole of this will be equal to cos 3 theta. So let's make this equation 1. So what do we need to do next? We need to want to prove that the left hand side is equal to right hand side, that this is equal to this. So but then we need to we'll start from the right hand side. So we need to think about the way we will split this, and also remember some of the trigonometrical identities. So but then we need to establish by saying that cos 3 theta is the same thing as splitting cos 2 theta plus theta, because if you add 2 theta plus theta will give you 3 theta, so cos multiply will give you this. So this just looks like the shape of the, what do we call it, addition formula, where if you have cos A plus B, you have the result to be cos A cos B minus sine A sine B. So in that, like, we want to also represent this one in that form. So cos 3 theta will be equal to cos 2 theta cos theta minus sine 2 theta sine theta. So this is how we just represent it, just exactly the way we've done this. But we know that cos 2 theta has a meaning in trigonometry, and the meaning of cos 2 theta is I think is cos square theta minus sine square theta. Is a formula. If you go through your trig identity, you will see that. And also we know that sine 2 theta has a meaning, and that is 2 sine theta cos theta. Is also there in trig. So I want to plot in these two formulas in these expressions. And how can I do that? It will imply that cos 3 theta will be equal to, in place of cos 2 theta, I want to replace it with cos square theta minus sine square theta. So I'll put it in bracket, cos square theta minus sine square theta, and this will multiply by cos theta. Again, we have minus, in place of this sine 2 theta, I will have to replace it with 2 sine theta cos theta, right? And then we have sine theta attached to it. So what will be the next step from here? It means that cos 3 theta will be equal to, we need to use this to distribute, and if we do that, this multiplies by this, we have cos cube theta, and this will be minus sine square theta cos theta, right? Minus, if you use this to distribute, we have 2 sine square theta cos theta. But you need to remember that cos square theta plus sine square theta is equal to 1, right? If we agree to that and decide to make this sine square theta the subject of the formula, it means sine square theta will be equal to 1 minus cos square theta. So at that point, in place of this sine square theta, I can easily replace them with 1 minus cos square theta. So let's do that right away. So we then have cos 3 theta equal to cos cube theta minus, keep in mind that this one will give us, we just open bracket and have 1 minus cos square theta, and this will multiply by the cos theta that is there already, right? Minus, here we have 2 into, then we have, in place of this sine square theta, we replace it with 1 minus cos square theta, and then multiplies it by the cos theta that was there. So this is a good step. So the next thing we will need to do at this point is to distribute. So I'll say cos 3 theta will be equal to, I'll have cos cube theta, and then I will use this cos to distribute across this by clearing the brackets. That means cos theta multiplies by 1 we give cos theta, and then cos theta multiplies by this cos square theta we give cos cube theta. But then we need to be careful because of this negative sign. So if you want to make it more easier, I want to still leave the negative sign and use this to multiply by this, so that I will have cos theta in bracket also, and then if I use this to multiply this, I'll have minus cos square or cube theta, right? If this multiplies it to give cube, right? So similarly, I will also want to leave this minus 2, so that I will use this to clear the bracket, and if cos theta multiplies by 1, that will be cos theta, and if it multiplies by cos square theta to give cos cube theta. Alright, so the next one will be cos 3 theta equal to cos cube theta, then we have minus cos theta, minus will affect this to be plus cos cube theta, and then minus 2 times this will give us minus 2 cos theta, and minus will affect this to be plus 2 cos cube theta. I hope this is clear. So the left hand side will still retain cos 3 theta will be equal to, notice that this cos cube theta can add up with this cos cube theta to give 2 cos cube theta, and also it's common to this, so that means the 2 cos 2 theta we have cos cube theta plus 2 cos cube theta will give us 4 cos cube theta, and then what happens to this term, we have minus cos theta minus 2 cos theta, and that should give minus 3 cos theta, right? So if we compare this with the previous equation one we stated earlier, we notice that we got the left hand side to be this, and we are proving the right hand side, which is this, and the right hand side has given us exactly this value we had at the left hand side. Look at it. If you compare that, I think you're having 4 cos cube theta minus 3 cos theta, which is exactly what you're having here. So because they are the same, it means we just conclude that since the left hand side is equal to right hand side, it means that we have proved it. It is proved. So that's how simple it is. So I hope this video was helpful. Please hit the subscribe button, turn on the notification bell, and please like this video, share this video, comment if you like the approach towards this problem.